Okay, good morning, all of you. Am I audible?
Yes, sir.
Okay, so just wait 1 minute. I am starting. Okay, so good morning, everyone. So my slide is visible. Anyone is confirming my slide is visible or not?
Yes, sir. Yes,
Okay.
sir. Visible.
Yes, sir.
Okay, thank you. So we have discussed in last classes, this is in control system, there is different types of mathematical modeling of different types of network circuit. So I think all of you seen this carefully in your room because I am uploaded this class notes in your Google Classroom. So please, this is reading carefully. So there are different types of examples we have discussed in last classes. Okay, this is mathematical modeling of the RLC circuit. Previously we discussed the mathematical modeling of RC circuit. Okay, then we have to discuss these are the LCR circuit. Okay, and finally we have to discuss the two different network. This is first network, and this is the second network circuit we have to discuss. Okay, so this is basically helpful for our next part. This is the transfer functions design. So today we have to discuss this is transfer functions. Okay, so just recall them. We have discussed in firstly control system. In it is two types. This is open loop control system. Another one is the closed loop control system. So all of you seen this is the basically one block diagram, open loop control system. So in this open loop control system there are two parameter. One is the input variable, another one is the output variable. So this input and output variable, it is connected. This is the one system, or that is this is called the transfer functions block. And we have to write what is the transfer functions ratio. Transfer function ratio, that is the TFR. It is ratio between the output variable to the input variable. So here you can see this is no feedback, it is attached in this open loop control system. Okay, so this is only for open loop control systems. Another one we have to discuss, this is the closed loop control system. Okay, so this closed loop control system, there are, we have to attach one feedback loops. Okay, so all of you seen the previous classes also. In this feedback loop control system, we have to use this two type of feedback network. One is the positive feedback, another one is the negative feedback circuit we have to attach. So this closed loop, it is divided into two categories based on the nature of the feedback signals. Okay, that is what type of feedback we have to attach. So one is the negative feedback, another one is the positive feedback. So this negative feedback control system, it is our feedback control system, closed loop control system. It is sometimes it is also called the degenerative feedback. Okay, another one is the positive feedback control system, that means, or also closed loop, or obviously these two are the closed loop control system. It is also called the regenerative feedback or regenerative feedback control system. Okay, so in this diagram here you can see this is the basic block diagram of the one uh, closed loop control system, and as well as it is also negative feedback closed loop control system. So this is the input sections, and in these input sections we have to uses the RS. RS means that is the input variable we have to attachable here to the summing point or set point. This is called the summing point, set point, or reference point. And this set point, it is also connected to the one controller part, which is control the overall options, overall plant or process or plant. Okay, this is denoted by the GS, and here GS, it is the transfer functions in the control system. Okay, this GS, it is also connected another one HS. This is called the feedback loop or feedback path. Okay, so this feedback path, it is connected in the summing point in the negative sign here you can see. So that's why it is called the negative feedback closed loop control system. So this transfer function, it is a negative feedback system. It is generally less than the one, and the closed loop, that is a closed loop transfer function, it is a finite value as long as the denominator is the select to the greater than it is 0. So this is called the negative feedback uh, closed loop control system. So when this is also positive region we have to attach, this is called the positive feedback loop, and this negative feedback closed loop control system, it is also called the degenerative feedback control systems also. Okay, so I just recall one things again. Here we have to use different types of parameter. This is input, this is denoted by the RS, and this is the summing point or reference point where we have to connect it. One is the controller part and another one is the feedback loop bar or feedback part. So this controller part we have to denote that is signal is coming, that is ES. Okay, this ES is signal is coming from the summing point or reference point input signal to the controller part. This is GS, that is the controller part. That means these are the basically transfer functions from we have to calculated here. And another one is the output section, that is CS. CS is the desired output section. We have to conclude the output section. Another one is the feedback loop or feedback path we have to use as here. Feedback loop, it is uses is the HS. Okay, so we have to conclude this is the negative feedback, because here you can see this is the reference input or summing input point where we have to connect it here negative regions. So that's why we have to call this feedback loop, it is a negative feedback loop, and it is also it is called degenerative feedback also. Clear? It is clear, all of you? Anyone any doubt or any questions? So please ask me. Please, anyone, any questions or any doubt? Okay, so we can go next, another one. So this represents of this gain of the total feedback loop. So these are the basically represent the gain of the all blocks in the forward path, and H represent the gain of the all blocks in the feedback paths also. Okay, so we can easily write this from the figure. So first one we have to conclude, one is the output sections. These are the basically we have to conclude in this section. CS is the output sections. So we have to write CS, that is equal to GS into ES. GS into ES, these are the basically output equations. Okay, and another one ES, this ES we have to denote it here, which is coming from the reference input signal to the controller part. So this ES, that is equal to RS minus HS into CS, where RS is the input point minus, that is a difference, to the feedback path, that is the HS, into CS, that means the output part. Okay, so these are the basically two functions we have to return from the diagram, block diagram reduction, block diagram techniques. First one, that is CS, that is equal to GSES. and another one is the ES, that is equal to RS minus HS CS. Okay, so equation 1 and equation 2. Now we have to difference between the or subtraction between the equation 1 and equation 2. So we have to easily write that is ES equal to RS minus HS GS into ES. Okay, so easily we have to write it here, that is RS equal to ES, that is a common part. This ES, it is converted in the another side, then ES is common part, that is 1 plus HSGS. Okay, so what is the ES? Here you can see this ES, that is equal to RS by 1 plus HSGS. So this is the number 3 equations we have to calculate it from here. Now subtract equation 3 in equation 1, that means ES, and here you can see that is CS. So we have to conclude it, that is CS equal to GS into, we have to put it this value, this ES, this value we have to put it here. So that is RS by 1 plus HSGS. Clear? So particularly we have to draw the block diagram. These are the basically block diagram. Here you can see this is the input section. We have to denote it, that is RS. Okay, another one is the CS is the output part, and this is the basically controller part. That means we have to write in, this is the transfer function of the controller part, that is GS by 1 plus GSHS, where GS is the transfer functions, HS is the feedback loop, and overall we have to calculate it from the above equation, that is RS equal to GS by 1 plus GSHS, that is equal to CS. So we have to conclude this equation, that is CS, this is the output equation, divided by RS, this is the basically input equation, that is output by input. We have to know that is the ratio between the output variable to the input variable. This is called the transfer function ratio, that is TFR. Clear? So we have to conclude this equation, that is equal to GS by 1 plus GSHS. Okay, so this is the basically transfer function of a given function or given diagram. Clear? Till now it is clear, all of you?
Yes, sir.
Anyone any doubts or any questions, so please ask me. Okay, so we can go next. Another one is the positive feedback. So now it is considered for the negative closed loop or negative feedback closed loop system we have to consider here. Now we have to consider the positive feedback. Here you can see this is the basically positive sign. This is the positive sign. Okay, so this is same thing diagrammatically, basically same. That is the input point we have to denote it, that is RS. This is the reference point or input set point where positive input is connected here, and another one is the feedback loop, it is also connected here, positive connections. And this is the transfer function, that is a controller part which is control the reference point or set point through the signal of the ES. And finally we have to process this output from this section, that is the CS. CS is the output from the following parameter of following actions. So this is a basically positive feedback closed loop control system. So now we have to conclude this figure, the number one, that is CS, CS equal to ESGS, we have to know. There is ES, that is the set point value, into that is the GS, means is the transfer functions value. Number 2, that is we have to return, that is ES equal to RS plus HSCS, because here plus sign it is coming, because this is a positive feedback, because this is a positive signs here also. But in the negative feedback, this is a negative symbol, that's why we have to return here ES equal to RS minus HSCS. Clear? This is the basic difference between the positive feedback and negative feedback. Now we have to calculate this equation 2 and equation 1. We have to return here, that is ES equal to RS plus HS into ESGS, because we have to know the value of CS. So we have to easily put this CS equal to ESGS into these equations. So the equation is coming ES equal to RS plus HS into ES into GS. Clear? Now here you can see these are the basically common part. Here you can see this is ES equal to, this is both side are changes, that is RS equal to ES minus of these things. But in this case, ES and ES is common part. So we have common both, that is ES common part, that is 1 minus HS GS. Clear? This is equation number 3 we have to written here. That is ES equal to RS by 1 minus HS GS for the positive feedback loop connections. Okay. So now we have to consider the equation 3 and equation 1. So here equation 3, here you can see, and equation 1. So we have to written that is CS equal to ESGS, but we have to put this ES value. These are the basically value of ES in these equations. So the equation is coming, that is CS equal to GS into RS by 1 minus HS GS. Okay. So you can easily write the transfer function of the given format, that is output by input. We know that CS equal to, that is the output, RS is the input sections, that is output by input, that is equal to GS by 1 minus GS HS or HS GS, something like that. So this is the transfer function of the positive feedback control system. Okay, so now this equation and this equation, in the negative feedback, that is GS by 1 plus GS HS. In the positive feedback, that is equal to GS by 1 minus GS HS. So please remember these things. So now this equation we have to draw this parameter, that is input. What is the input here? That is RS is the input, CS is the output sections, this is the controller part, that is GS by 1 minus GS HS. This is a transfer function. Clear? So here you can see you have to give in this type of equation, that is this type of functions, this type of block diagram, and you have to implement this block diagram according to our rules. We have to conclude the transfer functions. So that type of short problem it is coming from for your exams. You have to give in this type of figures, okay, something like that, and you have to convert this block diagram into the transfer functions. Okay, it is clear? Please confirm me, anyone, it is clear or not?
Yes, sir.
Okay. Next, another terms, that is the unity feedback systems. So this transfer function, it tends to very large value as GH is approaches, that is 1. It is generally used in oscillators, that is first one, that is the unity feedback systems. So this is a basically unity feedback where the output it is also connected to the reference point or set point. This is called the input, this is input, this is output, this is a feedback loop, and this is the controller part which is denoted by the G. So this unity feedback system are those in which the feedback factor, that is HS, that is H equal to, that is 1. So when feedback gain, that is H, value of H, it is equal to 1, this is called the unity feedback system, and this is the basic following diagram for the unity feedback system. Next, so we have to learn from the above equation for the negative feedback. We have to written here, that is CS by RS, that is output by input. This is equal to G by 1 plus G, or when we have to use the feedback loop, that is GS by 1 plus GSHS. But in that case, here you can see feedback factor is, that is H equal to 1. So that's why G into 1, that is value of HS, that is 1. So G by 1 plus G into 1, that is G plus 1 by G, 1 plus G. This is for the negative feedback equation for the unity feedback system. Another one is the positive feedback system, that is output by input sections, that is CS by RS, that is equal to G by 1 minus G, because here H is H equal to, that is 1, that is G by 1 minus G into 1, that is 1 G by 1 minus G. So this is basically negative feedback, and another one is the positive feedback. for the unity feedback systems. Okay, it is clear, all of you? Anyone any doubt from this part? So please ask me. Okay, so next we have to conclude another part. Now, one important terms, conversion to a unity feedback system. Okay, so here you can see this is a one closed loop system, closed loop diagram we have to present here. Okay, so this is a basically closed loop system where the R is the input sections, that is the reference input or the set point we have to denote it here. But here you can see this is a negative. Okay, that means this network, it is a feedback network or feedback negative feedback systems. So this is the H is the feedback loop, this is the output section, this is the controller part, G is the controller part. So this any closed loop system, it can be converted to an equivalent unity feedback systems. Okay, we have learned in previous questions. So from the negative feedback, we have to retain the transfer function from this, that is transfer function. TF means that is the transfer function in the control system. So please remember these terms also. TF means that is transfer functions. So this TF for the negative feedback system, that is equal to G by 1 plus GS HS. Okay, so that's why we have to shortly we have to write G by 1 plus GH. Okay, so this is the basically negative feedback system transfer functions. Next, multiply and divide by the H, that means the feedback. So transfer function it is coming from, that is TF equal to 1 by H dot GH by 1 plus GH. Clear? Where H is the feedback and G is that is the controller part also. Okay, so again we have to return that is transfer function, that is equal to 1 by H dot G dash by 1 plus G dash, where G dash that is equal to GH. What is the GH? Here you can see this diagram also. So this is the input part we have to attach here, that is the R. This is the basically 1 by H part we have to multiply in these sections. Another one, that is the reference part. Okay, this is the G and H part. What is the G and H? G is the controller actions part, H is the feedback loop system. And this is the output section from the C is the output. This output loop, it is connected from this section to the reference point input. And this feedback loop here we have to use this, that is a BS. So this GS, that is a forward transfer functions, or sometimes it is also called the direct transfer functions. This GS, HS is the feedback transfer functions, where we have to use the feedback loop. Then when GS into HS, it is called the loop transfer functions or open loop transfer functions. Clear? So this is basically difference in the closed loop and open loop control system. And when CS by RS, that means the CS means that is the output sections, that is the output variable. RS is the input variable, that is output variable by input variable, that is CS by RS. This is called the closed loop transfer functions, or sometimes it is called the control ratio. Okay, so please note down these terms also. Thank you. Okay, so this is the basically control ratio functions. So this CS by RS, that is equal to closed loop transfer functions, and this is denote for the control ratio. Another one, when any error it is occurring, or error you have to calculate it. So this is the basically error corrections or error corrected value, that is ES by RS. ES means these are the basically ES from the reference input we have to collect it here. So this ES by RS, This is called the actuating signal ratio. Sometimes it is called the error ratio also. Okay, so please note down it. When ES by RS we have to use this in our transfer functions, this is called the actuating signal ratio. Okay, and sometimes it is also called the error ratio also. Clear? Next, another one. This is BS. Where BS? BS is connected from this unity feedback loop. This is the unity feedback. And this unity feedback we have to connect it from the output section to the reference point or set point also. So this BS by RS. So this BS by RS, this is called the primary feedback ratio. Okay, so in the when we have to solve the mathematical related problem, these terms it is also important for the particular parameter we have to calculate it. So please everyone see this carefully, then we have to go the next. And anyone any doubt or any questions, so please ask me. Okay, it is okay, all of you. Please confirm me.
Yes, sir.
Okay. Pranav, you take a screenshot right now for the attendance purpose, and all of you please write your own name and roll number in the chat box also.
Okay, sir.
Okay. Okay, so just I am recall them. So this is a basically one negative feedback circuit we have to use as here. These are the basically different input point, output point. This is error point, error signal we have to calculate it. This is controller part, this is feedback loop. So we have to easily write the transfer function from this negative feedback circuit. This is TF, that is equal to G by 1 plus GH. And when we have to multiply and divide by the H, that is the feedback functions. So transfer function it is coming, that is TF equal to 1 by H dot GH by 1 plus GH. Okay. So now we have to written that is transfer function TF, that is equal to 1 by H dot G dash by 1 plus G dash, where G dash that is the G into H. This G, when G and H it is multiplied, this time it is called the open loop transfer functions. Okay, so this is the basically one another circuit, another blocks we have to draw. This is the input variable that is multiplied by the 1 by H, that is also reference point or set point we have to calculate it here. This is ES, that is the error point value we have to calculate it here, which is connected to the controller part. This is GH, that is open loop transfer controller part, and another one is the output part, that is C. And this is BS, that is a unity feedback we have to connect it from the output to the reference input point. So now these terms are basically very important. Here GS is the forward transfer functions, and another one is it is called the direct transfer functions also. So GS is the forward transfer functions, or sometimes it is called the direct transfer functions also. Another one HS. HS is the feedback transfer functions also. Okay, so please remember these terms also. And when GS into HS we have to use this is called the loop transfer functions or open loop transfer functions also. And when CS by RS, that means output by input variable. So this is called the closed loop transfer functions, that is output variable by input variable. Sometimes it is called the control ratio, or sometimes it is also called the TFR. Sorry, this is called, sometimes it's called the TFR. What is TFR? TFR means transfer functions ratio. Clear? So please everyone note down it. TFR, it is called the closed loop transfer functions. It is also called the control ratio. That is TF equal to output variable by input variable, that is CS by RS. Next, another one, when error ratio we have to calculate it, that is equal to ES by RS. These are the basically ES signal from calculated here. This is the RS, that is the input signal. So this ES by RS, this is called the actuating signal ratio, or sometimes it is called the error ratio. Okay. Another one, this is the basically feedback ratio. This feedback, it is calculated the unity feedback system, that is a BS to the input variable, that is BS by RS. This is called the primary feedback ratio. Okay. Next, analysis of mechanical systems. Okay. So this is a basically mechanical system, whether transitional or rotational or obey the basic law, the sum of the different types of controller actions. So this is called the mechanical system. Just wait, I am sharing the another screen also, and everyone write your name and roll number in the chat box also. Okay, so this is another one. So now we have to conclude this block diagram representation of this control system part. So first question you have to arise, what is block diagram representation of a system? So block diagram. So you can just remember the last slide also. Here we can see there are different types of blocks are present in a control diagrams also. That is a reference input, then also the error point, that is a set point, then also controller part, okay, then output variable, then also we have to connect the feedback loop or unity feedback system. So these are the different blocks. So this block diagram of a system is a pictorial representation of the system's functions. It functions performed by the each component and representation of the signal flow. These elements of a blocks diagram are blocks. Okay, and this is also branch point and summing point. It has different types of. So I just recall one thing again. What is block diagram? So a block diagram of a system, it is a pictorial representation of the system functions performed by each component and representation of the signal flow. Okay, this element of a block diagram are blocks or branch point and summing point. So these are the basically block diagram elements we have to use this in the block diagram representation of a transfer functions. Okay, now so this is a basically one equations. So this is a basically one blocks, that is the input, another one is the output variable, this is the transfer functions. We have to conclude in the previous slide also. In this block diagram, all system variables are linked to each other. That means input variable, it is connected to the transfer functions, that is the controller part. Then this controller part, it is also connected the output variable, the output unit. Okay, so this is a basically functional block diagram. This arrow, this is the basically arrowhead. This arrowhead is pointing towards the block, indicates the input, and the arrowhead reading away from the block represent the output signals. Okay, so this is a block diagram. All system variables are linked with each other block or part through the functional blocks, and this arrowhead it is pointing towards the block indicates the input, and the arrowhead reading away from the block represents of the output. So these transfer function of the components are usually entered in the corresponding blocks. Next, this is the basically first block we have to consider. It is clear all of you? What is blocks? Please respond me anyone. It is clear or not?
Yes, sir.
Okay. Next, we have to consider the reference point or set point. Okay. So we have to conclude this summing point. This sometime it is called the summing point, sometime it is called the reference point, or sometime it is called the set point. So in this fifth semester, you have to read the control system, and when you have to seventh semester, you have to read the process instrumentation and control. This part, it is also common part. Okay, so please remember these things also. This part it is same in the next another semester subject in the seventh semester, process instrumentation and control. So this is a summing point. Sometimes it is called summing point, sometimes it is called set point or reference point. These summing point are also used to add two or more signal into the systems. So here you can see this is a basically one input, that is A is a number one input is added here. Another one, number B is the second input here attachable here. This is the basically sign magnitude, positive, negative. Sometimes it is called the positive. That means the positive feedback network. Another one is the negative feedback network. It does not matter. The sign is changes or not. So in this summing point, we have to use the adding the signal two or more. So that is A and B. So this is A, that is negative, that's why with the result here A minus B. Okay, so this is called the summing point. Clear? So summing point, why use the summing point? Summing point we have to use in the control action but transfer function for the adding two or more signal into the systems. Okay. Another one, next, branch point. What is branch point? Branch point means where the branches are occurring in the different forms. So here you can see this is the controller part. G means that is a controller part. This is the output part here, and here this is the number one input. We have to attachable here, and this is the one another branch. This is the another branch we have to connect it. The another device or another part also. So this type of diagram it is called the branch point. So this branch point it is very important for the part of the control actions. Different branch point we have to calculate it in the controller part. Okay, just tell me one thing. Today's second half any blank schedule? Pranav, please tell me today's second half any blank schedule is present or not? Anytime second half. Anyone please tell me any blank schedule today is present? Sorry? Sorry, please tell me once again, any blank schedule is present or not?
No, sir. Lab has a second half.